We see them absolutely everywhere nowadays. They are printed on everything, but how do they actually work? Well, those blocky little squares filled with chaotic black and white pixels have a shortcut called QR code, which stands for Quick Response Code. To understand them, we first have to look at their grandfather, the classic barcode you see on a cereal box. A regular supermarket barcode is just a single row of vertical black lines. Your phone or a grocery scanner reads it from left to right like a sentence, measuring the thickness of the bars. Because it only goes in one direction, a regular barcode can only hold about 20 letters or numbers, which is just enough to store a basic product ID number. However, a QR code is an upgrade because it stores information in two directions at the same time, up and down and left to right. This allows a tiny QR code to hold over 7,000 numbers, or 3,000 letters. When you point your smartphone camera at a QR code, the phone doesn't just look at the whole thing at once. It first looks for three very specific anchors. Notice those three large, identical squares sitting in the top left, top right, and bottom left corner. Those are called position detection patterns, and they are a really important part of QR code. Their only job is to tell your phone's camera exactly where the code is and which way is up. Because of these three squares, it doesn't matter if you hold your phone sideways, upside down, or at a weird angle. Your phone's scanning app instantly recognizes those three corners, digitally rotates the image in a split second, and flattens it out so it can read the actual data inside. There's also usually a smaller fourth square hidden near the bottom right corner. This acts as an alignment marker, helping the phone decode the pattern even if the QR code is printed on a curved surface like a soda can or a crumpled piece of paper. Once your phone has aligned the image, it treats the rest of the grid like a giant digital map. Just like a computer screen is made of pixels, a QR code is made of tiny modules, which are the small black and white squares. To the computer inside your phone, every white square represents a 0, and every black square represents a 1. The phone scans the grid and instantly translates the visual pattern into a huge string of binary code. But the layout isn't random. Specific rows and columns right next to the big corner squares tell your phone what version the QR code is and what kind of data it is holding. The rest of the open space in the middle is where the actual message is stored. The phone reads these pixels in a specific zigzag pattern, jumping up and down through the columns to stitch the 0s and 1s back into words and website links. The coolest part about QR codes is that they are practically indestructible. Have you ever seen a QR code that was ripped, scratched, or covered in dirt, but it still worked perfectly when you scanned it? It is a built-in safety feature called error correction. When a QR code is generated, the software uses a special math formula to repeat the data multiple times within the pattern. It creates a mathematical safety net of backup pixels. Because of this clever math engineering, a QR code can lose up to 30% of its squares to scratches, tears, or stains, and your phone can still completely reconstruct the missing information. It calculates what the missing pixels should have been based on the surrounding data. And this will be all from me today. Thank you for watching, and I hope I will see you in the next one.